since all we did yesterday was pretty much watch the Magic School Bus, today we are going to do a writing assignment. We're going to practice our English skills and our science skills and our analytical thinking skills. So today, all you have to do, if you look at the Google slide, is read the background for the intertidal zone experiment and follow directions. A lot of y'all seem to have problems with that. You have to follow directions and do what's asked of you. And yeah. So, intertidal experimental design. So the first thing you need to do is read this first page. It explains what the topics are. If you didn't watch the lecture yesterday or didn't look at your notes, it explains what intertidal zones are, what pH is, if you don't remember what pH is. It talks about researchers. It talks about who Dr. Haley is. After you read this first page, you're going to get to a page that says procedures. This is what you're going to follow if you want to get a 100 on this assignment. So you're going to individually read the Ocean News article, Notes from a Scientist, Dr. Chris Harley. It is attached to the bottom of this. So if you scroll down the PDF, it's right here. I'm going to scroll back up. So you're going to read the article. When I read the article, to make it a little bit easier on me, I highlighted what the important information was as I went through the article. So I went through the article, I read it just like you have to, and as I got to information that I thought was important, I highlighted it. After you're done with that, if you have any questions about what's in the article, email me your questions. I don't get it or I'm not confused doesn't count as a question. I don't understand what they mean by, you're going to have to give me a little more guidance than just, I don't get it. I don't mind helping, but I need to know where to start to help you. After you've read it, you're going to summarize what you understood about Dr. Harley's work on a piece of paper. There has to be at least 5 bullet points or sentences. To show you what I expect, there is a page down here at the bottom that says summarize Dr. Harley's work. I gave you lots of room. I expect you to write in complete sentences and to summarize what he said thoroughly. Not plagiarize, do not copy, summarize. Put it in your own words. Once you have done that, you need to review the concept of experiments and scientific method if you don't remember those things. If you don't remember those things, there's a handout attached. This is Simple Scientific Method Notes. Miss Neal again went through when she read it and highlighted what was important. Once you review that, it says your challenge is to come up with a design that would allow Dr. Harley and his students to test how rising temperatures and decreasing pH will affect organisms that can be carried out on the shore. So your challenge is to create some kind of design that's going to create small zones on a rocky intertidal zone that's going to test temperature and pH separately. So you need to have one area that tests temperature, one area that tests pH, one that tests both, one that's your control. Once you've come up with this design, you are going to draw out your design on the page that says experimental design. It's down here. So it's right after the page where you wrote down So you summarize Dr. Harley's work. The next page, a second to next page, is your design. You're going to draw me a picture of your design here. You should have a pretty good idea of what intertidal zones are. You watched a movie on them yesterday, and I gave a lecture on them yesterday. If you need help, you can always go to Google. Once you have come up with a design, you need to write out the materials and methods. When you write out your materials and methods, you need to make sure that the following things are listed. The variables. What are the variables? What's different between each pool? What are the controls? What are the replications? How often are you going to replicate it? When are you going to replicate it? The data collection. How are we going to get the data? Where is it going to be stored? How, especially because it can get wet. It has to be able to get wet and function and dry. And so how you're going to collect the data, and then what materials you need. If you don't know what any of those things are, they're listed on this paper that says Simple Scientific Method. They're all here at the bottom. If I were you, when I was writing the materials and methods, I would use this as my guideline. I would start here at the top. Can't see my whole picture. I'd start here at the top, and I'd write about the variables, then the treatments, then the controls, then the replications, then the data collection, and then the materials needed. Materials needed, if I need a pencil to write with, you need to tell me that I need a pencil to write with. You need to be as inclusive as possible. Don't tell me to put it on the shore. How am I going to put it on the shore? Where am I going to put it on the shore? Am I going to just drop it on the shore? Am I going to set it down gently? Am I going to nail it in? Am I going to screw it in? How is this going to work? I need to be able to replicate it in its entirety. So I need to be able to read it like it's an instruction manual. It should take up, I gave you an entire page to type it out on or to write it out on. It should take up that entire page. So it should go top to bottom, the entire page, methods and materials. It should take up this whole page. In fact, if you do it right, you probably won't be able to fit all of it on this page. Because if you just tell me to take the temperature, that's great. I'm going to take the temperature with my head. I'm going to take the temperature by holding a thermometer in the air and seeing if it's the right temperature. I'm going to take the temperature of the water. I'm going to take the temperature of the rock. I'm going to take the temperature of the sea urchin. You've got to be super, super specific. Take the temperature of the water by placing the thermometer 2 centimeters into the water. I need numbers. I need specificity. After you finished all of that, so you have summarized Dr. Harley's work, you have written up your materials and methods, you've drawn a picture of what your experimental design is. On the last page, you're going to answer some questions about your experimental design. When you're done with that, turn all of that in. I'm going to give you 2 days to do this assignment. I know it's a lot. I'm going to give you Wednesday to do this assignment, and I'm going to give you Thursday. It's going to be due by midnight on Thursday. Some more things to take into account are, here's some more like checklists if you're having trouble with the experimental design. Here's some ideas. It says challenge checklist with constraints. These constraints are ideas to kind of help you. You want to create small compartments in the intertidal area that are accessible for observing. They must be open to organisms to move through, such as sea stars, crabs, and snails. Within each compartment, you must be able to alter the temperature. Within each compartment, you must be able to alter the pH. It can be set up over several different nearby rocky beaches. It doesn't all have to be on one. It needs to be anchored so it doesn't drift away at high tide or get moved to a location for following low tide. So it needs to be in the same place for high and low tide. And you have to be able to test temperature and pH in the compartments. If you have questions, feel free to email me. Again, you have 2 days to work on this. So if I'm giving you 2 days to work on this, I expect some pretty thorough work. Have a good day.